Start better.
Buoyancy in everyday life. Swimming in water. Anyone can be able to swim in water because of upward thrust exerted by water. Flying of
So,
bird or aeroplane. Sir, since air is a fluid, thus it also exerts upward thrust over the object. Therefore, because of upward thrust of air, a bird or aeroplane can fly in the air.
okay. So, where do we see buoyancy? One is swimming. When you swim in water, anyone can swim in water. Why? Because the water is creating a pressure upward. So it keeps you afloat, doesn't allow you to sink. Same thing you observe in bird and airplane. Because we are taking gas also as a fluid, it also exerts upward thrust on the object that is aeroplane and the bird. So because of this force or the upward thrust, aeroplane and bird can fly in the air. Now let's see what are the factors which affect buoyancy, please. Please continue. Hello.
Factors which affect buoyancy, volume of the object, density of the fluid, volume of the object. Buoyancy or upward thrust exerted by a fluid increases the volume of the object immersed in it. Density of the fluid. The buoyant force or upward thrust increases with increase in density of the fluid. Denser liquid exerts more upward thrust.
So what do we
This is
observe? Just a moment. So what do we observe? That buoyancy is affected by the volume and the density. It is directly proportional. More the volume, more will be the buoyancy or the upward thrust. Okay. So whenever any object is in the fluid, the volume of the object has got direct proportionality with the upward thrust. More the volume, more will be the upward thrust. Same way with the density of the fluid. For example, we take two fluid, one say water, another say oil. So we know that water has got low density than the oil. So denser liquid, that means oil. If I put two same objects in water and oil, in water the upward thrust will be less as compared to the oil. You understand? Do you understand? So both have got direct proportionality. More the volume, more the buoyancy. Denser the fluid, more the buoyancy. Did you understand?
Yes, ma'am.
Okay. Yes, read. Yes, continue. Yes, continue.
Ma'am, I can read.
Yeah.
Density of the fluid. The buoyant force or upward thrust
So this we've
increase
done.
with
This we have done. This is the cause. This
increase
is
with
the
volume.
cause.
वो वाला ना मिस.
We have finished this. You have to do the last stanza.
This is the cause that it is e- easier to swim, easier to swim in seawater rather than fresh water. Seawater is saline. Salt dissolved in seawater increases the density and hence it exerts more upward thrust than fresh water.
Okay. This is the reason that we can swim in seawater as compared to fresh water. Why? Because seawater is saline. Saline means salty. You know that seawater is salty. It's got lots of minerals in it. So whatever the salts which are already dissolved state in salt water, what it is doing? It is increasing the density of seawater and hence it is creating more upward force or upward thrust or buoyancy to the object, so the object remains afloat, it doesn't sink as compared to fresh water, because fresh water has got low density. Did you understand? Hello?
Yes,
If you compare seawater and fresh water, which is more denser? Which is denser? Seawater is denser than fresh water. So we will have more buoyancy, seawater. Less buoyancy, fresh water. Okay? Okay, boys?
okay, ma'am.
This is how we can find the buoyant force. This is spring balance. We have put the object. Okay. For example, this object is in air. So what will it say? The weight of the body in air is 60 gram weight. So it is in the air. Remember that. So buoyancy in the air. The same process we will be doing, which is partially immersed in liquid. Can you see this? It is half inside the water and half outside the water. Can you see this? This also gives 50 gram weight. Here what we got? 60 gram weight in air. When it is put in water, partially, means half inside the water, half outside the water, what we got? 50 gram weight. And here you can see it is completely inside the liquid. We get the weight as 40 gram weight. Why it has happened? We will observe this. Start.
The magnitude of beyond force acting on an object impressed in a liquid depend on volume of object impressed in the liquid
Immersed. It is
and
immersed.
immersed in the liquid and density of the liquid.
We have already studied that. What are the factors affecting buoyant force? One is volume of object, which is inside the liquid, or the weight of the liquid, it is density of the liquid. These are the two factors which categorizes buoyant force. This is just a revision because we have already done that. Yes, start.
As the volume of solid object immersed inside the liquid increase, the upthrust or beyond force also increase. When the solid is fully immersed, the beyond force because becomes maximum.
Continue.
The beyond force depend only on the volume, but not the nature of the solid object. That is, if two balls of equal size but of different metals are immersed in the liquid, both of them experience same beyond force.
Fine. Now we know that just now we found that the volume of any object which is inside the liquid, completely immersed inside the liquid, it is increasing. So what happens? The buoyant force also increases. And when we completely put the object inside the water, the buoyant force is maximum. Why? Because the force, the upward thrust depends on the volume of the object. Now, if I take two objects of different metals, same volume, that is equal size, the upward thrust will be same. The buoyant force would be same. If I take an object of glass and I take another object of steel, the buoyant force will be same. Did you understand? We see this in category. Start.
Liquids having higher density exert more beyond force than the liquid having lower density. It is either easier to
Yes.
swim in seawater than in lake because density of seawater is more when compared to that of lake water. Even an iron block can float on mercury because of its mercury high density.
Second factor is density of liquids. Now, what we saw, more density of liquid, more will be the buoyant force. And that's the reason that you can swim in seawater because seawater is higher density than fresh water, that is lake. Okay? Any problem? Any problem?
No,
You understanding what's happening? All day-to-day activities understood now? Buoyant force. Yes, begin.
why objects float or sink in water? If the density of an object is less than the density of liquid, it will float on the liquid. And if the density of object is more than the density of liquid, it will sink in the liquid. Take some more water in a beaker. Take a piece of cork and iron nail of the same mass. Place them on the water. The cork floats and the nail sink. The cork floats because the density of the cork is less than the density of water and the thrust of the water is more than the weight of the cork. The nail
Correct.
sink the nail sink because the density of the iron nail is more than the density of water and the thrust of the water is less than the weight of the nail.
You see over here, the cork is floating and the iron nail has sunk at the bottom of the glass. Can anyone explain why is it happening? Hello, boys, can you explain what we took? We took some water in a beaker. What we did? We took a piece of cork and an iron nail. It has got the same mass. Remember, so cork and the iron nail has the same mass. We put them on the water. What we'll find? That the cork floats whereas the nail will sink. Why is it happening? Because the density of cork is less than the density of water, right? So what water is doing? Water is giving a buoyant force to the cork. So the push from under the cork is making the cork afloat. Whereas in the case of nail, the density of iron nail is more than the density of water. So the upward force, that is the buoyant force, the thrust is less than the weight of the nail. So what happens? The nail starts sinking at the bottom of the glass. Hope you have understood this activity.
Yes,
All of you? All of you? All of you? That by the same mass is showing different type of activity. Have you understood or not, boys?
Yes, ma'am.
Okay. Same thing we're going to show with a different slide by objects float or sink in a liquid. So you can see a nail over there and a cork over there. The person is pushing the cork under the water, inside the water. Can you see this? This cork is being pushed by the hand. It is saying it is gone under the water. Okay. What happens? This cork comes up. When I'm pushing this cork here, after some time it will come up. Can you see this? This is the before and this is the after. So if I push, it will go inside the water. But when you release your hand, the cork will come up. Okay? Whereas the nail which is kept over here, after some time you will find it over here. You understand? Now you see what happens to an object when it is put in a liquid. Please start.
When an object is placed in a liquid, two forces act on it. Weight of the object acting downwards, which tends to pull down the object, and beyond force, a thrust acting upward, which tends to push up the object. Now,
What are the
whether an
forces?
object,
Just a moment. So what are the forces applied on the object? One is the downward force, that is the weight, right? It is a force. What is the force? Weight. You agree with me? Do you agree with me?
yes,
So downward force is the weight, and the upward force is the buoyant force. So two forces are acting on an object. When I place that object in the liquid, one is downward force, that is weight, and the other one is the upward force, that is buoyant force. Now see what happens. See, read.
now whether an object will float or sink in a liquid depend on the relative magnitude of these two forces acting in opposite direction. Three cases arise if
Arise.
the if the buoyant force exerted by the liquid is less than the weight of the object, then the object will sink in the liquid. If the buoyant force exerted by the liquid is equal to the weight of the object, then the object will float in the liquid where it is suspended. If the buoyant force exerted by the liquid is more than the weight of the object, then the object will rise in liquid and then float.
We got three parameters. First is that if this is the water surface and this is the object, right? This is water. If the buoyant force is less, this force B is less than the weight, what will happen? It will push more. Okay? Sorry, it will not push more. This is the object. I will show with small arrows. If the buoyant force is less, then the weight is the big one. Okay? That is big arrow. Then the weight. So what will happen? It will come down. It will sink. Right? Right? Hello.
Yes, ma'am.
Fine. Now we'll see the second one. This is the object. Now show same arrows. This is the buoyant force, and the same arrow is the weight. What will happen? It will float. Not more, not less. Okay. Third one. Again I take this is an object. This buoyant force is more. So I will show the big arrow. Then small arrow. What will happen? What will happen, beta?
It became float.
You understood now? That's why I've changed the size of the arrow so you can understand. Any problem?
No.
Why do we float? What are the principles? We'll do one by one. Please start.
The principle of flotation. An object will float in a liquid if the weight of the object is equal to the weight of liquid displaced by it. For example, weight of the object is equal to weight of the liquid displaced by it. A floating body may be partially or wholly submerged in the liquid. Wholly submerged in the liquid is displaced by that portion of the body which is submerged under liquid.
So why this is happening? Because this is water and this is the object. So it is displacing the liquid which is displaced by this immersion of the object. When you put something in the water, for example, let's take a mug and there's a bucket of water. Just observe. If you have not observed, then do it today itself. So what you're doing when you're putting the mug of water inside, the water level comes up. Have you observed that? Did you ever observe when you put the mug, empty mug, inside the bucket of water, the water level comes up a bit. Why? Because the water is displaced by putting the mug in the bucket of water. And later it becomes okay. Have you ever observed this?
Yes,
Hello? Okay. Why did the surface of the water come up? Because when I'm pushing the mug inside the bucket of water, the mug is displacing the water. That volume of water is being displaced by the mug. So the level of the water comes up. But when it gets filled up when the mug gets filled up with the water, the level of the water becomes okay. The same. That shows that whenever you're immersing or submerging an object in the water, the volume of water gets displaced by the volume of the object. Okay. So, for example, if this is the surface of water, if I have an object which is floating, that means this much of portion will be displaced. I take second category. This is the surface of water and half it is outside and half it is inside. Only this much of portion of water will be displaced. You, okay? You understand? Now, Fifth, take the third one and put this object under the water. That means this much water will be displaced. You understand now what is happening? So the volume of the object is important for the water to be displaced. Displace it. Please read.
The density of floating object. First, an object will float in a liquid if its density is less than that of the liquid. An object will also float in a liquid if its density is equal to that of the liquid. An object will sink in a liquid if its density is more than the of the liquid.
So now we are talking about density of the object. What did it say? The object will float if that is a D1 is less than this is water that is D2. Okay, this is D2. So the density of object, this one, is less than density of water, the object will float. Take the second instance. If the object D1 is equal to D2, that is water, then also it will float. Okay. Third, if D1 is more than D2, that is water, it will sink. Understood? Understood? Hello? Any problem regarding these two, three slides?
No,
Now we'll see an activity that how does a boat float in water. And if you can explain, I will be happy. Okay? Start. Start.
how does a boat float in water? When a boat is gradually lowered into water, it displaces more and more water, due to which the upward buoyant force acting on it increases. The boat stops sinking further down into water when the buoyant force acting on it just enough to support the weight of the boat. When the boat is floating, the weight of water displaced by the submerged part of the body is equal to the weight of the boat. When
What did you
most
understand? Just a moment. What did you understand by these three paragraphs? Do we throw the boat in the water? No. We slowly lower the boat in the water. You know that? We don't throw the boat into water, but what we do, we slowly lower the boat into water. So what is happening? More and more of water gets displaced due to the thrust, that is buoyant force. Then the boat starts sinking into the water. Yes or no? Hello?
yeah,
Slowly starts sinking into the water when the buoyant force becomes equal to the weight of the boat. then it does not sink anymore. It starts floating. Why? Because the weight of water which got displaced by the boat, which is inside the water, becomes equal to the weight of the boat. So the buoyant force becomes equal to the weight of the boat. It starts floating. Any problem? Next one is what happens when people start getting into the boat. Please read. Please read.
When more people get into the boat sink more. As long as the weight of the boat and the people together is equal to the weight of the water displaced by the boat, it floats. When no more water can be displaced by the boat, it sinks.
Understood now? So you must have heard so many cases of boat capsizing, the boat sinking with people, the people drowning with overcrowded boats. You must have heard all this in news. This is what happens. That when people get into the boat starts sinking because of the weight of the weight of the people, the weight of the men folk is adding to the weight of the boat. You agree? You agree? So when till the boat, till the weight of the boat and the people together is equal to the weight of the water displaced, nothing will happen. The boat will float. But as soon as the water don't get displaced by the people on board, it starts sinking. The boat starts drowning. You understand? The boat will go under the water and people may die. Okay? You understand or no? So you can see this one, the upper boat. See, this is the line. You see this line of the boat? And the boat is outside. See, this is the boat. Understood? The first boat I'm talking, this is the first boat when there are no people. See how much of boat is above the water, and look the second case. See, so much of boat has gone inside the water. Can you see this? This much has gone inside the water. You understood or not? Hello? Hello? Hello, can you hear me? Okay. This much you have understood? You can compare the first boat and the second boat. I'm just showing together. First boat, this much of ocean is outside water. And in second boat, let's take the Plimsoll line. We'll talk about from the line. This much is out the water. Whereas in the second, only this much is outside the water. See, can you see how much has gone inside the water? This is the comparison between the boats with people and without people. Hope you have understood. Hello, Now we come to the last topic of this chapter, density and relative density. We start. Yes, please begin. I can't hear you. Can anyone begin? I'm not able to hear you. Can you hear me?
Yes, ma'am.
Okay, please. You must have had some problem. Net problem. Please begin.
Density and relative density. Density. The density of substance is the mass of a unit volume of a substance. Density mass by volume. The unit of density is kilogram per meter cube. Kilogram meter. Second, relative density. The relative density of a substance is the ratio of the density of a substance to the density of water. Relative density is equal to density of a substance by density of water. Since relative density is the ratio of similar
Ratio.
quantities,
Ratio. It is ratio.
ratio of similar quantities, it has no unit.
Okay. So what is density? We know that density is mass per volume. We already know that. From 6th or 7th standard onwards, you know what is density. So it is mass per unit volume. So D is equal to M upon B. Okay, this is how you have to remember. What is M? M is kilogram. What is unit of volume? Meter cube. So you just have to put kilogram per meter cube. You understood? Hello. Now we come to relative density. What it is? It is the, when I'm talking about relatives, I'm comparing. When I talk about relatives, I'm comparing the density of two. One is the density of a substance with water. Understood? Understood? Hello? Yes. But when both are density, so unit has to be same. The unit gets cancelled. Okay? So what do we find? It has no unit. Any problem? Fine. Then I think we have come to close of today's session. It's already time. Just check. And we have done good job. I hope you have understood all new topics what we did today. Is there any problem to understand? Okay, fine. So hope you will have a good day, and I wish you all the best. Bye, beta. Bye.